Okay, so again today we're going to be talking about 4.7D, how to measure with a protractor using and measuring angles. So can you measure the angles? And let's look at this and see what we've got. Okay, here's our protractor. Remember we talked about it. It has an outside scale and an inside scale. If your bottom ray goes through this zero, you use the inside scale to measure. If your bottom ray goes through that zero, then you use the outside. So what you do is you take your protractor and you line it up to where it's even with the vertices. Looks pretty even to me. This one's going right through the zero. So even if you're doing in or out, to me it doesn't matter, but you do what your teacher tells you to do. I'm going to count and hop, so 10, it looks like it might be almost 20. So I'm going to say the degrees on this one is probably somewhere around 20. It's kind of hard to tell with this because it's not exact, but let's see what it is. 19 degrees, so I was pretty close. So that's kind of what you're going to do is line your protractor up. Let's go to the next one. Okay, looking at this angle right now, I know it's an obtuse angle. Why do I know it's an obtuse angle? Because I know it's greater than 90 degrees. So I'm going to take my protractor and I'm going to slide it to where that center part right here is sitting right there on the vertex of the angle. These are a little tricky. And I'm going to make sure that this bottom ray goes right through zero. Now, I can either count the inside measurements or the outside measurements. It really doesn't matter. So, whoops, it's not going to let me count it this way. Let's see if it'll let me do it this way. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Probably there's 105, 6, 7. It's probably somewhere around 107 degrees. Well, let's check and see if we're right. Well, maybe it won't let me check and see if I'm right. Well, wrong one. It moved on me. Well, I don't know what's happened here, but it won't let me click. But we're going to go ahead and say it probably is 107 degrees. And you can see it's between 100 and 110, and it's closer to 110. So it's probably 107. Let's move on. All right. Another obtuse angle. Why? I know it's greater than 90 degrees. I'm going to move this down. I'm going to set it right there on the vertex to the best of my ability. Try to set it on zero. Again, count 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 15, 16, 17, 18. Probably 118. Okay, 115, I'll go with that. Okay, let's keep going. All right, again, it's another obtuse angle. I'm going to slide it down here. Make sure that this lines up with the bottom ray. If it would let me, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 105, 6, 7, 8, somewhere around between 105 and 110, 107. Okay, let's keep going. All right, now I'm looking at this one. I know it's an obtuse angle. I know it's an acute angle because it's less than 90 degrees. So that means my measurement has to be less than 90 degrees. Let's see what we've got. I'm going to bring it right down here and line it up with a vertex. Make sure that bottom ray goes right through the zero. Start counting 10, 20, 30, 40, 50. I think it's probably 50 degrees. Let's see. We were right. It's 50 degrees. Let's look at the next one. Okay. Oh, I bet all of you know what this one is. How many of you think that's a right angle? I think it probably is, but let's check. So we're going to slide it down here. I'm going to make sure that center line lines right up evenly with that center. I'm going to make sure that bottom ray goes through the 0, and notice it's 90 degrees. So I think it's probably 90. It is 90 degrees. Let's go on. Okay, another obtuse angle. So I know that the numbers are going to be greater than 80 degrees. So let's slide this over, or 90 degrees, I'm sorry. Let's slide this right here. It's lined up in the center point, the vertex, goes through the bottom 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20. So it's probably around 120. Yes, it is. Okay, let's keep going. There's so many of these to practice on. Okay, again, obtuse angle, probably so. We're going to drag the protractor down. We're going to line the center point up right on the vertex. We're going to make sure that the bottom ray goes right through 0. And we're going to start counting 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30. Probably 130. Now, you're thinking, well, why aren't you just using the numbers on there? Because sometimes your protractor may not be lined up correctly, and it just makes a lot of sense if you will count and hop like you do on any number line. So we said it's a 130, and it is 130. Don't get confused with the fact, and this is why I ask you, think about what kind of angle it is. Because if you say that this angle has 50 degrees, then you are not thinking about the fact that it's an obtuse angle. Because 50 degrees would mean it's an acute angle. Okay, here's another one. Now, this change is a little bit different. The bottom arrow is going through another way. So, when I line it up right here, I'm going to look and notice that the bottom arrow is now going through this 0 side. So that means you're looking at the numbers on the outer part of the protractor, the outer scale. 10, 20, 30, 40, 50, 60, 70, 80. I'm going to say it's somewhere around 90. I'm not sure it's a right angle. It is. They're just showing you a different way that the bottom arrow is going through, or the ray is going through. Okay, again, an obtuse angle, but notice the bottom ray is going this way, so we're going to pull the protractor down, and we're going to set it right in the vertex. We're going to make sure that that bottom ray goes right through the 0, and we are going to count on the outside. We're going to use the outer numbers, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40. Oh, I'm going to say it's probably 145. Let's see. It's 145. Okay, let's see. We have a couple of more. Okay, now, this one we know is what? It's an acute angle, less than 90 degrees. So I'm going to slide it down here to where the vertex is. I'm going to line it up. I'm going to make sure that bottom ray goes through the 0. And we are looking, because it's going through this way, we are looking on the inside. And let's count. Looks like 10. It's probably 15. Let's see what it is. 14. Okay. Let's keep going. All right, here's another one. Now the angle's opening in the other direction. So I'm going to pull the protractor down. I'm going to place the center in the vertex. I'm going to make sure the bottom arrow goes, or the bottom ray goes right through the 0. And I'm going to count 10, 20, 30, probably 35. Let's see. It's 35 degrees. Let's keep going. All right, here's another one. It's an obtuse angle again. I'm going to bring my protractor down. I'm going to find the vertex where the two rays meet. It's going through the 0. I'm going to count 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, maybe 144, 145, 144. Okay, almost completed. Okay, a couple more. This one again opens up in this direction, so I'm going to pull the protractor down. I'm going to set it on the vertices, the vertex point where the two rays meet. I'm going to make sure that the bottom ray lines up through 0. It goes right through 0, so I'm going to use the outer scale. Looks like 10, 15, maybe 16, 15 or 16 degrees. 16 degrees. And I think we've got one more. Okay, again, looking at it, I know it's a obtuse angle. I'm going to pull this down, line it up, set it right in that vertex. Make sure that bottom ray goes right through 0. Start counting 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, almost 110. It looks like it's between 105 and 107. Let's see. Oh, this one's off a little bit. Now sometimes that happens, and it could be the way it's set in there, and this is not exact because it is on a smart board. I can't get it to 117, so I don't know if the person made a mistake or if the protractor is just not lined up right, but we can tell that it is at least either a 107 or 117. So again, today's lesson is 4.7D, and it talks about measuring with a protractor. We are going to show you more when we actually hand you a protractor. Be very careful with them because they are runoff, and it's real easy to erase the numbers. Also, they've been used a lot, so you need to make sure that you don't bend them because they'll bend real easy. See you later.